Good evening. I'm Spot On Weather meteorologist Matthew Euler, and tonight I'm going to go over the latest Teleconnections discussion dated today, Friday, the 23rd of October, 2020. There's a lot to talk about as we look ahead, moving into the latter part of October and early November. So let's take a look at the latest Teleconnections discussion. First, I wanted to show how to read this Madden-Julian oscillation forecast chart. And notice on this chart how the MJO is divided up into 8 phases, phases 1 through 8. And you'll notice some of the lines on this particular diagram. The black line shows the 20 days of observed MJO phase and the amplitude as well prior to initialization. The black asterisk on this particular MJO forecast plot denotes the start of the observations, and the numbers on the chart indicate the day of the month. Now the dark green line shows 45 days of the MJO phase and the amplitude from the forecast ensemble mean. The green asterisk denotes the start of the forecast, and again, numbers of the day of the month, with individual ensemble members denoted by the light green lines on this particular graphic. The phases overall, the phase of the MJO is indicating the approximate location of enhanced convection, whether that be in the Western Pacific, the Western Hemisphere in Africa when the MJO is in phases 1 through 8, whether that convection be in the Indian Ocean with phases 2 and 3, or phases 4 and 5 correlate to enhanced convection in the maritime continent. So I wanted to just briefly go over this. This is a nice graphic to kind of show you and introduce you to the Madden-Julian oscillation or MJO forecast. And it's the real-time multivariate MJO RMM index, which was proposed by Wheeler and Hendon back in 2004. So let's go ahead and move ahead. And I want to talk briefly about the MJO phases and where the areas of enhanced convection occur in the various phases of the MJO. If you notice phase 8, I'm going to basically work my way along with equatorial, tropical area, extending from just west of the international dateline all the way over to just off the coast of Africa, just off the southwestern portion of Africa. So working our way from right to left, you'll notice phase 8. That's generally where you see enhanced convection in the equatorial areas just west of the international dateline, or 180 degrees longitude, 180 degrees west longitude. As you work your way from right to left, you'll notice the numbers decrease to MJO 7, phase 7, MJO phase 6. MJO phase 5 is where you have a lot of enhanced convection in the vicinity of Australia, the northern parts of Australia. MJO phase 4 enhanced convection extends a little bit further to the west, and then MJO phases 1 through 3 show generally where there's enhanced convection in the Indian Ocean. And then finally on the far left, you'll notice that number 8 again, that's MJO phase 8, just off the western coast, the southwestern coast of Africa. So this is a really nice diagram when you're talking about MJO phase forecast and where the enhanced areas of convection are actually occurring in the equatorial areas. Where we're looking for that enhanced convection is going to correlate with the MJO phase. Now moving ahead to the actual MJO temperature composites, there on the left-hand side of the graphic, I'm showing you temperature composites for November, December, and January. The orangish shadings indicate above normal temperatures, and then the blue shadings indicate below normal temperatures. So you'll notice on this particular temperature composite, the correlation of the MJO phases, that phases 7, 8, 1 generally indicate cooler temperatures for the blue shading there, phases 8, 1, and 2, fairly cool temperatures for a good portion of the United States for the months of November, December, and January. So when we see MJO phases 7 and 8 and 1, it's generally cool across the eastern U.S., whereas phases 3, 4, 5, and 6 are very mild for a good portion of the United States with above normal temperatures. Now moving over to the graphic on the right, showing you the GFS Ensemble MJO forecast. And you notice that solid green line. We're currently in MJO Phase 5 with enhanced convection occurring over the maritime continent. But you notice how that green line pivots to generally to the left and to just lower left, going from MJO Phase 5, where we are currently, through MJO Phase 6 in a forecast. The inner circle there, by the way, that represents where the MJO is pretty much null and not really a factor. So if you see the forecast lines go into the very inner circle, that indicates very weak amplitude to the MJO and very little influence on the overall pattern of weather across the mid-latitudes. The further you get from that inner circle there on the MJO phase diagram, the greater the amplitude. So the GFS Ensemble forecast is for, again, we started in Phase 5, and we're seeing that correlation right now with fairly mild temperatures across the mid-Atlantic, with lots of above normal temperatures. Highs today in southeastern Virginia, we're up near 80 degrees. And over time, going to phases 6 and 7, so we would expect a slight cool down if this forecast were to verify, according to the GFS Ensemble. Moving on now to the GFS operational there on the left, showing, again, very similar track and forecast. You see the blue line, aqua color line there on the graphic on the left. That's the NSEP GFS, showing a transition again from the current MJO phase of 5 with enhanced convection over the maritime continent, moving over through phase 6 and phase 7, and extending more so now through November 6 out towards phase 8. The graphic on the right shows the Navy ESPC Ensemble MJO forecast, and this is indicating a general null phase. You'll notice the image on the right there, the graphic on the right, how that green solid line with the dots is generally in the very inner circle of the MJO phase diagram, which indicates very little amplitude in the forecast. All right, so now we're going to look at La Nina considerations. As I mentioned in last Friday's video, the graphic on the right shows sea surface temperature anomalies in degrees Celsius based on, because compared to climatology from the years 1981 to 2010. You see that blue shading there off the coast of South America extending along equatorial areas in the eastern Pacific. That is indicating below normal water temperatures. Right now, the latest in the Nino 3.4 region, we're looking at water temperatures at 1.3 degrees Celsius below normal in that Nino 3.4 region. That blue shading sticks out really, really evidently on the graphic on the right. The graphic on the left, I just wanted to show the December through February, the atmospheric circulation with La Nina conditions. And you'll notice the arrows represent a general circulation. What you have occurring is upwelling water. Much cooler water comes up to the surface as the trade winds increase from the east to the west and push the warmest water out towards the western Pacific Ocean basin. That's what that orangish and reddish colors indicate, above normal water temperatures in the western Pacific Ocean basin. The blue shading below normal water temperatures across the eastern Pacific Ocean basin. And you'll see the dark arrows. Those represent generally stronger trade winds at the surface, pushing the warm water towards the western Pacific Ocean basin. And above that, above normal water, you have rising vertical air, and you get these thunderstorms, enhanced convection areas closer to Papua New Guinea, into parts of the western Pacific. And you get sinking vertical air motion over the eastern Pacific Ocean. So this shows you a great vertical cross-section of the atmospheric circulation from December to February for La Nina conditions. Right now we're going to take a look at some of the Teleconnections forecasts. We're going to start with the Arctic Oscillation forecast. These graphics that I'll be showing for the actual forecast are courtesy of weathermodels.com. All right, so just as a reminder, the Arctic Oscillation, there's a difference between negative phase and positive phase. The graphic on the left shows negative phase, where we get a large dip in the polar front jet stream, and you get colder air that sinks to the south from the higher latitude areas into the lower 48. So you get this trough from the Midwest to the East Coast, and you get cooler air with a negative Arctic oscillation phase. Whereas the image on the right shows a positive phase of the Arctic oscillation, where you have pretty much a west to east polar front jet stream in a zonal configuration, and you really don't get a large dip in that jet. And also, between the negative and positive phase of the AO, notice where the low and high pressures are. With a negative phase AO, you have higher pressure up at the northern latitudes. Positive phase, you have lower pressure at the higher latitudes. So here's the forecast for the Arctic oscillation. This is the European deterministic model run for today, showing you there's a zero line. Any values above that zero line are positive, and anything below the zero black solid horizontal line there on these graphics is negative. The dates are at the very bottom of this diagram, and you'll notice the European deterministic starts the AO out in more of a negative phase here, and it's now starting to cross that zero line, becoming more neutral, and then rising. The forecast is for the AO to become positive. You notice the white dots above the black solid lines. The European EPS, the Ensemble prediction system, with 50 perturbed members, generally showing a positive, ultimately going to a neutral AO as we go into early November. The European EPS 46-day forecast. So this is the 15-day forecast. Now I move it out to all the way to early December on the 46-day outlook forecast here, showing a positive AO as we go into the first week of November, dipping slightly negative there around between the 11th and the 16th of November, and then again climbing above to positive, above that zero line, positive AO as we head into the third week of November into early December. And then finally the GFS deterministic AO forecast, showing again a rising tendency of the AO to a positive phase, if you notice, as we head into the first portion of November. And then the NCEP GFS Ensemble Forecasting System version 12, the Arctic oscillation with 30 perturbed members, is mainly positive above that zero line. Moving on to the outlook for the North Atlantic Oscillation, the NAO forecast. As a reminder, here's what you get with a positive NAO versus a negative NAO phase. You'll notice the jet stream is more zonal from west to east, with a positive North Atlantic Oscillation phase on the left. And you'll notice that area of warmth from Florida up into the Midwest, and a good portion of the East Coast, the eastern seaboard. With a negative NAO phase, keep in mind you get a very big dip in the polar front jet. You get very stormy conditions in the base of that long wave trough. And you also get what's known as blocking pattern, where you get higher pressure that builds, upper level ridge builds into Greenland across the North Atlantic. So it sets up a blocking pattern. On both sides of that upper level ridge, you get troughs or major dips in the polar front jet stream, and usually stormy and below normal temperatures. Taking a look at the NAO forecast now for the using the European deterministic model for today, 23 October. For the NAO, the European deterministic is showing a positive trend for the most part, going out through the first few days of November. The European Ensemble prediction system, EPS, with 50 perturbed members, is showing again a positive phase to the NAO, eventually dipping down to neutral territory closer to that zero line as we head into the first week of November. The European EPS NAO 50 perturbed members 46-day forecast, showing a positive phase of the NAO, and then dipping down slightly negative from the 6th of November through the 21st of November, and then back slightly positive beyond into late November, early December. The deterministic NAO forecast for the GFS, again showing a positive tendency for the North Atlantic oscillation from late October, remaining positive all the way up through the 5th of November, before dropping slightly into the negative phase of the NAO there briefly around the 6th or 7th of November, before becoming neutral once again around the 8th of November. Now, on to the Pacific North American PNA forecast. As a reminder for the Pacific North American pattern, when you have a positive PNA, that generally indicates a ridge in the west with above average temperatures, and then below normal temperatures and a major dip or trough, a long wave trough in the eastern U.S. So you get below average temperatures across the eastern U.S. with a positive PNA and a ridge in the western U.S. With a negative PNA, it's the opposite pattern. You get a trough or a dip in the jet stream across the western U.S. with below average temperatures, and you get a ridge over the eastern U.S. during a negative PNA, and you get above average temperatures in that case. So let's take a look at the model runs for the Pacific North American pattern. You'll notice it's fairly negative here in late October, and it stays negative pretty much until the first few days of, if you follow those white dots, the first few days in November it actually trends back towards neutral, towards that zero line. The European EPS, PNA, 50 perturbed members, 15-day forecast. Again, starting off with a negative phase of the PNA, eventually becoming neutral around the 1st of November, and then actually going slightly positive according to this model run, slightly positive above the zero line as we head into the first few days of November. The European EPS Pacific North American pattern, 50 perturbed members, 46-day forecast. Now this one goes out to 6 December, and you'll notice again as we head into the final week of October and the first few days of November, a positive trend to the PNA, and then neutral, overall neutral from there, from the 6th of November, pretty flat, that green line, as we head in through late November. The GFS deterministic PNA forecast showing a negative phase, eventually becoming positive briefly the first week of November, and then dipping back to negative around the 7th to 8th of November. And then the NCEP Jeffs version 12 PNA forecast, 16 days out into the future. We're going out to the 8th of November there on the far right. Starting off negative and then rising to neutral and then dipping negative again in the first week of November. Now for the Eastern Pacific Oscillation, the EPO forecast. Generally with the Eastern Pacific Oscillation, keep in mind with a negative EPO, this is the image on the left there, shows colder air descending from Canada into the eastern U.S. with a major dip in the polar front jet stream. And you get a high pressure system in the Gulf of Alaska, a ridge poking into Alaska with a negative EPO and a area low pressure below that. So high over low in the eastern Pacific. With a positive EPO, you get the opposite effect. You get a major low pressure system in the Gulf of Alaska. You got your high pressure systems situated around 20 to 25 degrees north latitude in the Pacific Ocean. And you get really warm and mild air, a mild Pacific jet stream with a positive EPO. With that zonal configuration from west to east, you get a lot of mild air from the west to the east coast with a positive EPO. So let's take a look at the models and the forecast for EPO. For the European deterministic, you'll notice a negative phase to the EPO. Eventually recovering here the last week of October up towards neutral territory before the forecast on the European calls for the EPO going positive by the 3rd of November. The European, this is the 50 perturbed members for the EPO, EPO, 15-day forecast showing again a trend towards a positive phase of the EPO. European EPO, 50 perturbed members for the 46-day forecast going out to the 6th of December. You'll notice again how the trend is for a positive EPO and then dipping slightly closer to neutral there around the 21st of November and pretty much remaining neutral around that zero line through the early part of December. And then the GFS deterministic EPO forecast, a lot of ups and downs in this particular graphic by the GFS, showing a negative phased EPO becoming positive by the last few days of October into early November before taking a major dip there beyond the 6th of November. And then finally the NCEP Jeffs version 12 EPO with 30 perturbed members on this model run, 16-day forecast out to the 8th of November, showing an overall trend from negative EPO to positive EPO the last few days of October into early November. And then finally for tonight's video, I wanted to show you the polar vortex forecast. Now the polar vortex is forecast to strengthen and remain over the poles through 8th of November 2020. You'll see the graphic on the left shows today's current polar vortex situation, and it shows that blue shading there over the north polar areas. Generally concentric, those white lines, fairly concentric looking pattern. And then the image on the right shows the 8th of November, and the white lines there, that gradient tightens up, and you'll notice that that polar vortex has actually strengthened based on the spacing of those white solid lines, and it remains up over the north polar areas. So no real sign of the polar vortex weakening at all based on these graphics. Now, here are my final thoughts on tonight's video. Looking at all the teleconnections, the MJO is currently in phase 5 and it's trending towards phase 6, which would be very mild for the eastern U.S., and then phase 7, which will still be relatively mild. The models are indicating a positive to neutral trend in the Arctic Oscillation through early November, with above normal to near normal temperatures in the eastern U.S. That would be the result of that trend. Models are indicating positive to neutral trend in the North Atlantic Oscillation, the NAO, through early November, with above normal to near normal temperatures across the eastern U.S. Models are indicating a negative to neutral trend in the PNA, though through early November, with above normal to near normal temps in the eastern U.S. And then models are also indicating a negative, becoming positive trend to the Eastern Pacific Oscillation, or EPO, through early November, which would yield above normal temperatures in the eastern U.S. And finally, the models are indicating a strengthening polar vortex through early November, with the coldest air remaining over the polar region, with a more zonal jet stream configuration and near normal. We'll see occasional above normal temperatures in the eastern U.S. So the overall assessment from Spot On Weather, based on the teleconnections, taking a really in-depth look at them for today, Friday, October 23rd, it's going to be a period of mainly above normal temperatures for the eastern U.S. between now and early November. There will be brief periods of cooler air with cold frontal passages and near normal temperatures, but overall we're looking at fairly mild pattern. We've seen that over the last week across the mid-Atlantic, for example, with temperatures pretty much dropping down to the low 60s overnight and rising between 75 and 80 during the day. So again, we take a look at all these teleconnections, the polar vortex, the EPO, and the various models that show that. The PNA, Pacific North American pattern, right? And then the North Atlantic Oscillation and the Arctic Oscillation, as well as the MJO forecast. And again, I really like this graphic because it shows you where the enhanced convection occurs based on the numbers here. Phases 1 through 8, and the models are pointing towards phases 5, 6, weaker amplitude towards phase 7. Most of the models are indicating the same forecast, the same direction of the forecast. So again, teleconnections is a very important forecast as we head into the latter part of October, especially into November, and then into the winter season as well. I'll be constantly giving updates on the teleconnections. My overall goal, hopeful to get out a video once per week at the end of each week on the latest updates on these teleconnection forecasts. Now keep in mind, this is these are the forecast models based on from the 23rd of October. These do change quite frequently, so we'll stay on top of it here at Spot On Weather. But just goes to show you that what happens in the Pacific Ocean, mid latitudes, weather moves from west to east. Whatever happens in that Pacific Ocean has a significant bearing on the weather across the United States. So we'll keep an eye on things. We appreciate your subscription to our channel, and thank you so much for your attention this evening. I hope everybody has a great weekend, and until next time, take care, everybody. We're Spot On Weather. If we're not spot on, we're not doing it right. Have a great evening, everybody.